Alright, hi everyone, my name is Bradley.
Hi, I'm Christian, and our project is titled Autonomous Driving, Interpreting Directional Clues in the Environment. So the purpose of our project was to create a script for our scribbler so that it will be able to autonomously drive safely while avoiding collisions.
And then to do this, we needed to be able to avoid the obstacles as well as reading different signs such as a red stop sign and arrows that would direct its turns.
So the hardware we got to work with this project was the Scribbler 2 bot as well as the IPRE flute that came with it. And on this flute came a multitude of sensors as well as the camera. And we mainly used the infrared sensor in order to make sure we can tell the Scribbler when it sees an obstacle so that it wouldn't drive right into it. And also we used the camera for image processing and color detection so that we can have our Scribbler detect what we want to detect and read what we wanted to read.
And then the software we used was a program called Calico, which we used to type out all of the code. And it's helped us to be able to find the mistakes that we made. And the program itself is written in the language called Python. And we use the Miro library, which have different commands to control the scribbler, such as taking pictures with the camera and using image processing.
So here's a sample code of our script, and we thought it's the most crucial part of our code, and it's a function we define as read sign. So basically, when the scribbler will get to an obstacle, it will call upon function, and if it sees that it's not just an obstacle, it's something you can interpret, it will go into read sign, and from there it will start an image processing procedure.
And then for the image processing, it takes all the darker pixels and sets them to black, and everything else gets set to white. And then for each of the dark pixels, it finds the x coordinate, so it can find the middle of the arrow. And whichever side has more black pixels, the scribbler will then turn and move in that direction.
So the procedures for our scribbler script are as follows. We'll put the scribbler into a course redesign which contains obstacles, signs, and traffic color sign. And so the script will move forward until it gets to an obstacle, and from there it will determine if it's just an obstacle or a sign you can interpret, and then it will follow that sign's directional clue as follows.
And then to be able to get through the whole course, we needed the robot to repeat this process of being able to move forward and keep reading the signs until it reached the red stop sign at the end.
And this is a picture of our scribbler doing this image processing. And so some of the challenges we faced during this project was actually learning and applying image processing. We actually entered this project having no prior experience to programming or using image processing, but as we went on, we were able to use the filters in order to make our scribbler see what we saw and do what we wanted to do. And also for determination of correct thresholds for color. So basically when a scribbler sees, or actually a computer sees a color differently than what we see, it sees the color as values, and we have to take averages of these values in order for our scribbler to see the color we wanted to see. And after we took the averages, we were able to get a good threshold for a scribbler to see the color we wanted to see.
And then one of the challenges that we faced was the scribbler, we needed to have it do right angle turns, so we had to make our own formula so it could turn in degrees. And then another big challenge was getting the arrow detection to work correctly, because at first, when we had to take the middle of the picture, if the arrow wasn't correctly centered, it would usually turn the wrong way. But by using our code instead, it's much better. And then overall, we were successful in our project. The scribbler was able to go through the course that we set up for it. And then overall, the arrow detection ended up being fairly accurate. And from the project, we learned a lot, especially with the image processing, being able to use image filters so the scribbler was able to read the signs correctly.
And for the application, could have been, if we had more time, we would have put the same code we had into more scribblers so that we can recreate probably what you see today as a normal traffic jam, or probably not even a jam, actually just driving along the road. And in the future, we hope to see this kind of concept applied to cars, and that we can drive along autonomously, safely driving cars while not having to worry about crashing while not even touching the wheel. And I'd like to thank our faculty in Cluster 1 for helping us with this project, especially to Matt and Kurt. Kurt actually gave us the idea of image processing, and Matt helped us perfect it. And and here's the demo.